All right, guys, welcome to another KevCAM night class tonight. Tonight, have Mr. Brendan McKenna helping out again. Brendan, how's things going?
Good morning. Everything's going well. No, I'm just kidding. No, everything's good. It's always good to be here with you, Kevin, and yeah, looks like we got some pretty exciting things in store for tonight. So I think we should have a good time here.
Yeah, absolutely. And for those of you guys that are new, and I got some good news for the regulars here, and I just kind of found this out today, but for those of you guys that are new, we use GoToWebinar, and everybody is in mute only right now. And if you guys do have questions, and which I hope you do, because like I said, you know, these classes are solely dedicated for you guys to learn and you know, pick my brain and pick Brendan's brain as much as possible. So. But so if you guys do have questions, there is a questions panel that you guys can ask those in, and like I said, feel free to ask as many as you want, and we'll get them addressed right away. Now, for the regulars, what I need from you guys is, so one of your guys' ideas was to have it so you guys don't have to register every time. So for those of you guys that want to be in the webinar every week now, you no longer have to register. But what I need from you guys is I just need you guys to send me an email letting me know, you know, who wants to be in every single night class, so that way you guys don't have to register every single time, and it will automatically kick you into the meeting just by clicking on a simple link. So and for those of you guys that don't have my email, let me get that for you here.
Yeah, and Kevin, you know, while you're doing that, you know, again, another good talking point here is, you know, we do keep everybody kind of on mute at this point, just to, or in what we call listen-only mode, just to make sure there's no background noise and stuff like that. But I'll be here to monitor the questions area. Anything that comes up along the way, just feel free to type in your questions. We'll get those addressed throughout the presentation, and make sure that each and every question is addressed as we move on.
Absolutely. I have a tendency to ramble on, so it's good to get broken up there with.
Hey, you know, they say that's a sign of intelligence, Kevin. So.
Well, they must be wrong. All right, guys. So what I'm also doing is I'm putting a link to the YouTube channel that we've started. For those of you guys that are new, bring it up here. We do record every night class and also do short little videos throughout the week. So our goal here is to, you know, release at least, you know, 2-3 videos a week for you guys on simple short little videos, and also doing the night class. So if you guys click that link, it will take you over to the SolidCAM University channel. And inside here we have tons of videos kind of going through, and I know this is a little bit of repeat for our regular customers here, but for you guys that are new, definitely come here, check it out. Tons of videos going through everything. And now if you guys want, you guys can hit the little search at the top right here and search for something specific. Or if you guys have an idea, which we get tons of great ideas from you guys, send those over to us, and we'll either do a whole night class on it, or we'll do a quick little video for you guys as kind of like a refresher, or you know, we have several ideas come in, and just, you know, how do you guys do this, and we'll just make a quick little video for you guys, and that way you get your questions answered at the same time as, you know, a couple hundred other people get that same question answered. So but I guess with that being said, we'll oh, and if you guys do submit a idea in, we'll send you a free hat, some SolidCAM swag. So send those ideas in. Let us know what we can do to improve it. Like I said, these classes are just for you guys. So anything you guys want to see different, change, added, you just let me know. So, all right.
You know, hey, Kevin, if I can just jump in here real quick before we get started. You know, that's a really great point that you brought up. You know, suggestions, comments, you know, things like that. Like we really try very hard to listen to everything that comes in. You know, Kevin's on the support staff. There are I think like 6 or 7 other guys on the support staff all the way, you know, throughout the country. And if you call in and you suggest something, that doesn't just go into some black hole somewhere. We're always listening. We're always trying to find ways to improve SolidCAM. And a lot of the new stuff that we come up with are based upon customer suggestions. So we really encourage you to do that. So if there's something that you see along the way, like Kevin just said, if there's something that maybe could you think could be a little bit easier, whatever, don't be bashful. Just go ahead and try to just type it in or suggest it or whatever. And we always look at that stuff, very, with a really kind of, like a solid attitude, and we just want to make sure that we're paying attention to all of that stuff and making sure that, that we are paying attention to what you suggest. And, we'll always make an effort to try to put those suggestions into the software.
Customer-driven software.
Absolutely. Yeah, definitely.
All right, so what we'll be covering tonight is one of my favorite toolpaths in HSM is 3D constant step over in rest machining. We're going to kind of go over a couple parts that we've done in the past using some linear, some constant Z, and just kind of show you what they'll look like now with using a 3D constant step over. And then a lot of our parts we're going to kind of integrate the 3D constant step over along with the rest machining. So for this particular part here, we have everything roughed out, so just a standard part here, probed it up real nicely, roughed it out using 3DI machining with a couple different size tools, and now we basically want to approach it with to finish off this part here. So first thing what I'm going to do is I'm going to add a 3D constant step over here. Now, a lot of these menus are all the same throughout all the HSM. There is a couple new ones in the 3D constant step over, and I'll kind of go over those real shortly on what those buttons do and kind of show you how the toolpath changes. But there's a lot in here, and I know it looks a little bit overwhelming, and that's kind of why we're going through these video series explaining these. But like I said in the past, the default values that are actually in here are pretty well set. And it all depends on the part that you're using. So, so for this particular one, we'll get the ball rolling here, and I'm going to basically kind of machine it off with a ball end mill here. Let me just see what I have. We'll use a 1/4 inch because we got some pretty small areas in there. And then what we'll do is we'll actually come back and do a rest machining and clear out anything that's left over. Now, 3D constant step over, I'll explain the toolpath, kind of how it works here, it's kind of like what it's saying. It's constantly stepping over vertically and horizontally, and you guys can set those numbers up. So this toolpath works great for a lot of different molds, a lot of different 3D parts. It's a very good general basic one, kind of lays a blanket over everything, getting nice toolpath, getting nice finish, depending on step overs and whatnot there. So it's like I said, it's one of my favorite HSM ones, but just kind of show you how it works here. So what I'm going to do right now is I'm just going to leave my drive and my constraint boundaries the same. Now, like we've talked about before, drive is kind of following the path that you want to go. Constraint is, where do you want to constrain it to? And I'm going to leave those to automatic just for right now. And I'm going to show you a couple different ways to do this. Now, passes. Like I've said in the past, is leave your passes, your step overs large at first. Let's get that toolpath looking the way that you want, and then we'll come in last thing and tighten up all our tolerances and tighten up our step over to get a good finish. And that way we're not wasting time doing saving or waiting for it to calculate. So from right here, basically just pick the tool, and I'm just going to do a quick save and calculate, and let's just see what we have so far. All right. So now you can kind of see we're starting in the center of the part and just doing basically a 3D constant step over. So now this particular one I'm not too thrilled with because I really don't want to start in the center of my part. I want to start on the outside, which is easy enough. So under your link page, One of the new buttons that kind of pops up for this particular operation here is from first pass, and it's basically reversing it. So do you want to start from the inside and go out, or outside and work your way in? So let's just switch that around real quick. And now we're starting on the outside and working our way in. Now, one thing I want to kind of show you guys here is if we do a kind of a straight down shot, you'll see it's kind of doing a square. So like right here, we get into the square corners and we're kind of squaring off everything. And it's kind of following that contour all the way in. Now, if you guys want a specific contour, what you guys can do is you guys can come into your drive right here and do a manual. And what we can do is, let me just kind of get zoomed in here. And I'm just going to do my tangent propagation. Hit OK here. Now if I do save and calculate, my toolpath is actually going to kind of follow that form around versus the outside box. You can zoom out here for you guys. And you can kind of see now we're kind of doing circles going around versus, you know, having those sharp corners there. We do have a little bit more repositions in here just because we're not doing those square corners. We're actually doing nice rounded corners in there. But it follows that central kind of decor in here, following that the general shape of that by picking that as your drive boundary. Now if I wanted to, what I could do also is to clean up some of my repositions is right now I'm set just to do one way. So now if I go to my link and do bidirectional, basically doing zigzag, will actually clean up my toolpath. So now we get a pretty nice toolpath there and working its way around. So instead of kind of coming back around here, lifting up and then coming back over, now we're just kind of doing a nice little zigzag pattern working our way out. So that's a nice thing to have, is that drive, so you can kind of follow, you know, you're kind of telling it to follow that shape throughout. And that can be on another part that we're going to be doing here. We'll actually just draw a sketch just off in La La Land, and it will follow that particular contour.
Yeah, you know, and Kevin, if I can just jump in real quick, yep. That's really one of the greatest things that a lot of people don't really pay attention to when you're kind of looking at the efficiency of the toolpath. You know, Kevin just made, you know, a couple of quick adjustments there to make sure that the, you know, you're not like, you know, rapiding up, down, back, forth, you know, all that sort of stuff. Just made a couple of quick adjustments, and then to make sure that the tool is always engaged in the cut itself. And, you know, that's a huge, you know, like a huge control feature that a lot of other systems really don't have. You know, they're limited to, you know, they kind of regionalize one area, then they kind of jump back and forth and all that sort of stuff. So the efficiency of the cut is really what's supremely important here. And, you know, I was really glad you were able to show that there, Kevin.
Yeah, absolutely. It's like there's a lot of stuff in here to control it, and we're not even, I mean, we could kind of come in here and even fine tweak, you know, our little links between slices here if we wanted to, and even fine tune it even more. So, but like I said, I mean, it all depends on how much time you want to, you know, spend on it. For, you know, a quick job, just trying to get out the door, you know, basically just pick your tool, your drive, and your constraint, or you can just leave it automatic and pick bidirectional, save and calculate, run that part through and get it out the door instantly. So that's a nice feature. Or, you know, if you need to spend a little more time on it, you can come in there, and that's the nice thing I like about SolidCAM is we don't lock you out of anything. You know, when I used to do SurfCAM and MasterCAM, they really lock you out of a lot of features that you wish you had control and you actually don't. But all right, enough comparing CAM systems here. Okay, so now we have our toolpath there. I'm liking what I see so far, so now I'm going to come back to my passes, and I'm going to tighten that up, because, well, if we just do a solid verifier right now and kind of show you what it's going to look like, it's not going to be the most pretty because we're actually doing a 40 thou step over. But, you know, for a 3D constant step over, it's a pretty nice toolpath. Now let's get in here and let's tighten up our step overs so we get a little nicer finish. And this is why I
You
like
know, the other thing too,
oh, go ahead.
Oh no, I'm sorry. I was just going to say, Kevin. You know, that processing time. You know, that's pretty impressive. You know, can you maybe just talk a little bit about what you're running for a system right now?
Yeah, this is this computer is actually fairly old. This is my smaller computer. It's a Dell 6800. Run the i7 4 Gen here, 8-core processor. That's the nice thing with the HSM module, 3D machining. Pretty much everything except for your standard profile face mill is all going to use multi-core threading, and what I mean by that is it's going to utilize all the processors. So we actually had a guy a few months ago. He had, God, it was like 26 or 27 processors, and
Yeah.
you don't even see a calculation time at all. It's just instantly. But
well, you know, and it's cool. You know, again, Kevin, I'm sorry to butt in here again, but just wanted to remind people that that's a standard feature in SolidCAM. You know,
Absolutely.
if you're on a network that has, you know, like multi-cores, if you have, you know, 20 cores or 40 cores or whatever it is, it doesn't matter. SolidCAM will automatically, and as a standard feature, look for those unused cores to process that toolpath. You know, so it's never going to interrupt anything else that you're doing on your network. And but again, it'll take advantage of those unused cores to process that stuff even faster. So, and a lot of, you know, there are a lot of other CAM companies out there that charge a lot of money to do that, and that's a standard feature in SolidCAM. So
yeah, another nice feature is when you guys do the save and calculate in parallel, you can actually pick a different computer. So if you have a real powerhouse, you know, a server computer, you can actually do all your calculations on that computer and keep programming and not have to wait for anything at all. So
totally.
And that's why I like to say, you know, keep your step overs large to start with. Get that toolpath looking nice. That way you're able to see, because, you know, now that we've tightened it up to 10 thou here, I really have to zoom in and kind of get a good look at what's going on with the toolpath. So it's going to save you calculation time, and it's also going to, you know, be a little bit easier for you to see what's going on. So, okay, so let's do a simulate here. Play her through real quick. And I'm not running very accurate, you know, so I'm only running a 4 thou accuracy, so I'm not going to see, it's not going to look as pretty as it would on the machine. And the only reason I have it cranked up to 4 is just so we're not sitting here waiting for for it to do the simulation, and we're just not putting you guys to sleep here. But you can see you got a real nice, you know, finish on there, getting in all the areas that we need to. Just that tool is just basically going back and forth. And like I said, this is a real good tool path for, you know, a real basic, easy tool path to use for basically any 3D parts that you guys have. So now that kind of goes into our next talking subject here, rest machining. So now we came in here with a 1/4-inch end mill, and obviously, you know, we have much smaller radii in here. It's giving me an arc length, but areas that we can't reach with that 1/4-inch. So we want to come back and rest machine it out with a smaller tool. So easy enough. All I'm going to do is just do save and copy. Switch this over to rest machining. I know we've talked about rest machining a little bit in the past here, but today we'll actually kind of dig more into it and give you a little bit more detail about it. So switch it over to rest machining. Going to grab a smaller tool here. I have something small. Yeah, a little 1/8 inch, perfect. And I'm going to leave my, I'll just do my automatic here. So it kind of it will contain it to the entire part of the model here. Reference tool. What size tool were you running previous? So we can just put, you know, 0.25 in there. You can make it 0.26. Now this number will depend on, I'll actually play on a different part. We'll play with this number a little bit and kind of show you the difference of what's going on there. And now passes. Same thing as before. You guys have your step down, step over. You got your bitangency angle here. The cool thing now is when you pick rest machining, you have multiple different toolpath options. We can do spiral on surface, we can do a linear or a spiral. So depending on what you guys are looking for or what kind of finish, you guys can actually pick how you want it to rest the rest of the material out. And for those of you guys who don't know, rest material actually stands for remaining stock. So that's kind of why it's called a rest material. But so what we'll do is I'll just kind of match my step down that I had in the previous operation, which was 10th thou here. And we'll do save and calculate. And now it comes in and cleans up all the areas that got left behind with that smaller tool. So not wasting any machine time machining the entire part over. It's just coming back and looking at what was left over from that previous tool based off that reference tool and coming in and machining it out and doing a nice spiral pattern in there, getting that material out of there. So, and we're going to be covering a lot of the parts that we're going through tonight. We're actually going to do 3D constant stepping over and then doing a rest. So get a little bit of repetition for you guys, and hopefully you guys will catch on a little bit better that way too. But same parameters. We can come in here. You know, with any HSM, we can do an actual offset here. We can do a gouge check against fixture. You know, you have all your strategies here. The only thing with the HSM rest is you can only use it with a ball end mill or a lollipop cutter. And that's just so it can calculate what was left over. So to kind of come in here with a straight flute end mill coming up at an angle, it just isn't going to work. So it doesn't need to be that ball end mill. But like I said, for you got all your strategies, your retracts, everything is all the same for you guys for HSM. So the only things really different is reference tool, and then under your passes, you have how do you want the toolpath to look. So any questions at all with this particular part right here? All right.
Yeah, not so far, Kevin. Just one request to maybe talk a little bit more, or even create a video on the comparison of different hardware specs. We were talking about, you know, multi-core processing.
Oh, sure. Yeah.
Yeah. So that actually, you know, that could be a pretty good suggestion for maybe a future class.
Yeah, absolutely.
You know, just how to kind of apply that. So
I'll have to get into the nerd side of things and get my nerd hat on and talk computers.
Yeah, but you're not already. I mean.
Oh yeah.
Sorry, buddy. I
No.
Can't help myself.
There we go. Got rest. Okay. So now, here's another part we kind of did, and I already have some toolpath on here. Like I said, we did a 3D machining, get everything roughed it out with just a little bit smaller tool here. And you know, before we did the HSM constant Z, so we're getting that nice wall finish in here. And this one we're just going to be covering is just the rest machining only. So if you come in here, you'll actually, let me do get in this one, simulate, do a solid verify, get everything updated, and you'll see kind of what we're left over with here. Kind of do a stock target. So we have some material still in those corners right there, and a little bit along that bottom radii right there. So what we're going to do is just come in here with a rest machining. And you don't have to do a save and copy. You can, excuse me, definitely come in here, do your add milling, 3D HSM. We got rests already selected here, and grab a small little tool here. Let's see. Okay, go with that. 1/8 inch. Leave, you know, let it be to the automatic, and I mean, I basically want to rest out any material that's left over. Reference tool, we were using I think it was a 375 cutter. So we'll just put 375 in here. And passes. Test my memory here, I'm thinking it's 7th thou, but okay. I'm just going to save it real quick here because I just want to make sure my step over was 7 on this one. And oh, that's our horizontal, sorry. And our step down. Oh, we're at 13th thou. Okay. So I can come in here and actually do that same 13th thou. Now, that's kind of nice thing too is, you know, if you guys just need a quick get out of here real quick, don't want to bother doing save and calculate, you guys can just hit the save button, exit, and everything's saved for you. And now it's going, basically looking for where any material is left over. Just to turn on this. And so now I'm actually coming down here in the bottom. And this is a little bit more tolerance than anything, but I already came in here with a flat end mill and cleaned all that up. So I really don't need to touch that again. So to come in here to fix that, just click your Z bottom and pick that area, save and calculate, and that will basically avoid that area because I have no need to go back in there and with a ball end mill and clean out corners. So you can see right here, it's coming in, cleaning out those areas. Basically, we're just working its way around using that spiral feature. We can do linear, probably is not good on this one, but we can do like a spiral that kind of goes past, but really we're not going past the material at all. So I guess for this one, we'll just leave it on spiral on surface. And if we kind of zoom in here, we can see we're basically doing a nice spiral starting from the inside working way out and getting that leftover material there. Now, we'll still have some material left over with that 1/8 inch. So what I can actually do is come back again and do another rest. So if I just do a save and copy here, and we'll just switch to a smaller tool. And constraint boundaries are going to be the same. The reference. Now, I'm going to show you the difference here. So technically, we had a 0.125 cutter in there. Now, if I leave it at 375, it's pretty much going to follow the same steps as what was left over from this one. If I just do a save and calculate real quick. And we'll turn that one off. Pretty much looking the same toolpath as what we had before, and that's because we still had that 375 reference in there. Now, if we can do our 0.125 here, and then it's just going to clean up what was left over. But you guys can also take this number if you want, and maybe you just want to do a little bit more of an overlap from the previous tool, so you could do like a 200 thou, save and calculate. And now it's just cleaning up what was left over from 200 thou diameter of that tool, even though they were running a 125. So we'll get a little bit of an overlap and a little bit nicer a blend doing it that way too when you guys are doing a multiple step downs using that rest machining. So like I said, this part, not much to it here. Just kind of want to really kind of focus more on how the rest works here, kind of going through and just kind of, like I said, cleaning up what was left over. Now, if you guys wanted to, like I said, with the levels, if you guys want to contain it to a certain height-wise, that's going to be right here in your passes. So maybe instead of Z top, I wanted to start a little bit farther down. I can actually click, somewhere down here, and it wouldn't actually start that till that start point. So, any questions on this part right here?
No, Kevin, I don't see any questions coming into, the immediate chat area. The one thing, though, that I wanted to ask you, I noticed when you're doing your part rotation and you're kind of zooming into that, that seems really smooth. Are you doing something different with that, or what are you using to kind of show that?
Let me show you guys here. If you guys are the boss or you guys have bosses, get them to spend money on this. Let's see, what is it called? 3D connection.
Oh, I thought so. Yeah, I thought you were doing something kind of cool there. That's killer.
So for you guys, you can get these pretty cheap. They have, so here we'll do 3D mouse. So here is a Spaceball, is basically what I call them, or a space mouse. This is what I use to pan, zoom, in and out, rotate. It's you know, a little puck. Well, actually, I have the big monster here, but I mean, I can get you know, densities, volume, all that popping up. I can actually read my email up on these screens too, but they have a bunch of shortcut buttons. But if you guys are looking for something simple, easy, these little pucks right here, I think they're $100, and it really makes your life a lot easier as a rotation. For those of you guys that are in the Solid Verify a lot, you'll notice that the zoom feature, since it's not our proprietary product for the Solid Verify, is a little bit different. When you guys are using the Spaceball, let me just do a simulate here real quick. Get this roughed out. All right, so now normally, you know, here I'm rotating with my mouse, and if I need to zoom into an area, I can't, like this top corner, I can't get it. You can do the mouse jockey doing it that way, or you can use your Spaceball, and I'll just put my mouse kind of off the screen, and you can really zoom around. It really makes things a lot easier. Everything is consistently the same all the way through, so if you guys are looking for make your life a little bit easier, that's the way to do her.
Yeah, Kevin, you know, wasn't, you know, trying to derail anything. Just, you know, that's really that's a pretty important part of this. You know, when you're looking at your design, looking at the model, trying to see it from all sides, you know, you have complete control over that. So, you know, just wanted to bring that up.
The efficiency of it was really nice too, because if you guys do spend a little bit more, you have these little buttons right here, and you guys can set those up for whatever you want. So if you want to do a quick sketch, you just hit one of the shortcut buttons on here and set it up. So it's pretty cool, real easy to use. So
yeah, very nice.
Okay, so what we'll do is go into our 3D constant step over. This is a part we kind of covered with, I think we were just talking about HSS Express a couple months ago, but now what I want to do is basically machine this part throughout. So if we do a top-down view here, you'll actually notice my walls are tapered, so they're not just straight up and down walls. And we have, you know, a nice radius at the bottom with a flat floor, and some really kind of funky top geometry here. So you know, with these Toolpaths, I mean, we can do you know, linear, we can use HSS, we can use, there's tons of different Toolpaths out there, and it's whatever you guys more want. Like I said, we want to give you as much options as possible. So, but I'll just kind of show you what it's going to look like here with a 3D constant step over. Go ahead and grab a tool here. Yeah, we'll go with a 1/4 inch. I'm going to leave my drive and constraint all the same. Passes, I'm going to leave everything where it is. Let's just do a quick save and calculate. And throw our toolpath on there. So we're starting at the center, working our way out. I kind of want to reverse that here, so let's start on the outside and work our way in. Now, like I was talking before, if you guys wanted to keep those edges rounded instead of the square, we can come in here and do our drive. You know, kind of follow the general shape of that cutout in there. And now we have nice rounded corners going all the way around. Now, one other thing I can do is turn it to bidirectional so we can get some zigzag, a little bit less retracts going on.
And, you know, as Kevin, as you're doing that, I mean, I just have to say here, I mean, you know, if you're looking for complete toolpath control, I mean, this is pretty much it. I mean, you know, it's amazing that you can just, you know, just make these, you know, just simple corrections and have, you know, all of that control over the toolpath just like that. I mean, that's immediate toolpath control. That's like, it's pretty much unheard of.
Yeah,
You know, you
real
just
nice.
don't see that. Yeah.
Real nice. So, and right here, I mean, so I got my toolpath, you know, what I'm looking for here. Come back, let's tighten up our, you know, our tolerance. Let's just do a 10th step over, real small scallop. Looking for, you know, a pretty decent finish here. Save and calculate. And we'll play this through. There we go. And let's go ahead and do a solid verify.
Yeah, you know, even that solid verify, I mean, it just gives you such a great picture of what it's going to look like.
Absolutely.
You know, as it hits the machine tool.
And like I said, you know, I'm running these tolerances. Let's see, what are we running for accuracy here? Yeah, we're still running 4th. And I'm, you know, normally if I was doing this, I would definitely have those tightened up. You know, if you guys are looking for a good recommendation on what to have that, you know, it depends on, you know, what you're looking for. You know, the more detail, the tighter to the tolerance you want to go, but the longer it's going to take to calculate. But, you know, I like to have mine, you know, right around 5/10 to 1/10. That way I can really zoom in there into a tight corner and see exactly what I'm going to see on the machine. But just for time's sakes for you guys, I don't want to have you guys putting you guys to sleep waiting for it to do the toolpath. So that's a little tough thing about HSM and doing 3D parts is they do take a little bit of time to do the simulation just because there's so much surface area. I mean, we're taking, I mean, this part is, let's see, we're 5 inches by 2.5 inches, and we're doing a toolpath every 10th step over and step down, so pretty tight there.
Yeah, you know, and Kevin, I was just going to mention too, you know, if you really want to take this to a whole different level, you know, we do offer a product called Machine Simulation, which will allow you to do crash detection. Well, this will obviously do crash detection with tool holders and things like that, but you could take it to a different level where you can show full machine simulation, where you can show, you know, guarding, fixturing, you know, all of that sort of stuff. And you know, again, Kevin, not trying to get you off course here.
He's making me find a machine sim for you guys right now. I should have had it.
Well, you know, I mean, you know me, Kevin. I have to set the bar as high as possible. So, you know,
give me
throw you right into the fire.
I mean, we can use a Hazy UMC. And
Kevin hates me right now. That's what he's thinking. I know it. I can feel it.
Hopefully, everybody's laughing right now.
Okay. Well, you know, you can't hear it, but you know, you can feel it.
All right, and the only thing I need to find is, let's see, 1.85. So I'm just going to put that in my setup for my Z. 1.85. And now let's do a simulation. Machine sim.
Yeah, and Kevin is completely doing this out of pity for me for mentioning it. So, you know, no, I appreciate it though. You doing this, Kevin, because you know this is really important. I mean, especially if you're, you know, doing some more detailed work, even you know, particularly mill turn, you know, that kind of stuff. I mean, this level of detail can be very, very important. So, you know, you'd much rather see any errors here rather than, you know, seeing them. Yeah, obviously out on the shop floor.
Yep.
So
yeah, they tend to be a little bit cheaper on this side of things.
Yeah, definitely. And the cool part about this is this is all built into your post processor. So anything that comes out of the post is actually what you're going to see on the machine itself. So and it's relatively inexpensive. It's really not that expensive to add this to you know, to whatever level package you have. So.
Yeah, and you guys will see right now.
I appreciate you doing that.
Yeah, you guys see right now I'm kind of got tool in La La Land, and that's just because I didn't put a tool holder on this one right here. Wasn't expecting to do machine sim on it, so I didn't have a holder on there. But normally you guys would see your guys' tool holder in there and with full crash detection and probably a vise on there too. But it's kind of, for the guys that haven't really seen the machine sim, I mean, you can kind of see the whole machine doing everything, or if you just don't want to see everything, we can just kind of turn off the outside boundaries and just get the 5-axis in the head. So.
Yeah, very cool. Thanks for doing that, Kevin. I appreciate it.
So now let's get into some more 3D constant step over, and just trying to look, okay, we're doing a 5-axis contour now. Okay, so we did this part, I think last week, doing the HSM boundary machining, and yeah, I think it was just boundary machining that we're actually doing on this one. So I just kind of want to revisit this one and show you guys what it's going to look like with the 3D constant step over. Super, super easy, and that's kind of why I really like this toolpath. Is really easy to use. So we'll go ahead and grab our tool here, and I'm going to leave my drive constraints all just as set to automatic. Passes, we'll leave it open right now. Save and calculate. Let's just see what we have. And pretty simplified, easy 3D toolpath there. Now, I am starting from the outside, working way in. Now, if this is something that you guys always want to do, if you guys always want to start on the outside and work your way in, you know, and it's defaulted to start from the center and work its way out. Easy enough. All you guys have to do is just turn this, excuse me, this particular feature on, and just hit the save button as a template. And then what you guys can do is you can actually load those templates in. So every time you guys start a HSM operation, it's going to automatically have that checkbox turned on for you. So we'll just start from the outside, work our way in, and easy as that. Let's go do a solid verify here. Player through. And got a nice toolpath there. Now, like I said, we do have a fairly large step over, so you're going to see all your little lines in there. But like I said, keep those wide open until you get with what you are looking for. And then now we can come back and, you know, if you're looking for a mirror finish, not 50, maybe we could do even a 5 thou, save and calculate. And, you know, basically this part could come off, and I mean, you wouldn't even have to touch it. It's would almost look like a polished mirror. Simulate here, and we'll just play this through for a quick little bit here because it's going to be a lot of step overs, but you can definitely see the surface finish is going to be much cleaner. And like I said, we are running a large tolerance right here, so it's not going to look as nice as it would, you know, if I tightened up the tolerance for you guys, but you're not seeing any of those step over, scallop, cusp heights, or anything like that. So but the flip side of things is, you know, the tighter the tolerance, or the tighter you make that step over, the more cycle time you're going to have on the machine. So it's, you know, it's totally up to you guys. You know, if you're looking for that mirror finish instantly, crank her down to, you know, 2 thou, 5 thou, 8 thou. If you guys are looking for a little bit of rougher finish but faster cycle time, and then you come back with a little bit of sandpaper, you know, open that up to, you know, 15 thou. So.
But I think, you know, Kevin, I think that, you know, really what needs to be kind of discussed here is the fact that if you use 3D eye machining to, you know, to rough out that surface area, you know, you don't need that intermediary step to do, you know, like the semi-finish.
Yep.
So, yeah, and I'm sure that's what you're trying to show here. So, you know, that's really the advantage. You know, you don't have to worry about going back and you know, taking like or having like, you know, an intermediary step and you know, machining again and then going back over the surface to take off that, you know, last, you know, 5 or 10 thousandths. You know, you can do that pretty much all at the same time.
Yeah,
so
absolutely. You know,
yeah, and like, go ahead. No, don't.
No, I was say, you know, if you guys wanted to too, like, you know, right now we have it, you know, pretty well roughed out. But you know, if we get out of here, go back to our 3D machining, maybe we just want to leave, instead of 15 on the wall, we just want to leave 5, so we're not overloading our tool here. And maybe instead of doing a scallop of 82 thou, maybe we want 30 thou. Save and calculate real quick. That cold that will never go away.
I was gonna say, I do understand that there's a lot of marijuana up in your area there.
Yeah, right.
Oh, I'm kidding. I'm joking.
Okay, so now you'll see we have nice, it actually finishes up even better here. A little bit more step downs in there, just roughing it out, so which would make it even easier on that ball end mill. But like Brendan was saying, if you guys are using 3D machining, there is no need to do a semi-finish pass on 90% of these tool paths that are out there. So okay, we'll mosey on to another part here. Now this week I tried to get as many parts as possible so I could just show you guys as much as I could. Let's see. This is the one I'm looking for. Okay, so you guys remember seeing this part a couple times here. We kind of covered it using the horizontal, linear, spiral, but you'll also notice that it was only working on specific areas. So now with this part here, I can actually cover the entire area of this part and basically have a finished off part here without having to come back with anything else. The only spot that I won't be able to fully get is, since I'm running a ball end mill, you'll see we have sharp corners, 90-degree corners from here and here, and obviously we'll have just a little bit of material there, but we can actually just come in there, buzz it out with a quick profile, or our HSM horizontal that we kind of covered in the previous night classes. So we'll come in here and do our 3D HSM. And I am going to do my 3D constant step over. Yeah, I'll go with that 1/4 inch ball end mill. I'm going to leave my drive and my constraint boundaries all the same. Passes, kind of leave everything the same. I know I want to start from the outside, so I'm actually going to remember it before I hit save and calculate. And we'll get some Toolpath on there. And this part is fairly large, so the calculation time does take just a hair bit longer.
Well, and again, Kevin, again, that really wasn't that long. And, again, just a reminder for, the other people that have joined us, multi-core processing, standard feature. Yep.
Okay, so we're starting on the outside, working our way in. Now, one thing I want to kind of throw out there is, in that first couple parts that we're talking about, that drive, now I have a lot of circles, especially this inner circle here, and we have a lot of round areas kind of coming off of that. So what I'm going to do actually is, instead of following the outside silhouette of our square, which is actually picked by our automatic target here, I'm going to actually tell it to do a circle here. So what I actually did is, let me just turn this toolpath off, is I just threw a quick circle in there. Let's start from scratch here. So what I'm going to do here is I want to kind of do a circle from right inside there. So what I'll do is I'm just going to give it a somewhat top down, do a sketch. We'll do a quick little circle. And we'll accept that real quick. And now I can come into my manual, grab that circle that I just picked. Now I'll do a save and calculate here. And now it's going to basically follow that circle kind of geometry, and we'll get a little bit nicer finish on these circle areas right here. But that's the nice thing, that, you know, we can make all these changes right on the fly, draw and sketch a geometry in there and whatnot, and this sketch will never go back to the original design model. So, okay, so now we're doing circles in here. You'll see on the outside we're still kind of following that same flow of that circle going all the way around. Should get a little bit nicer toolpath or a little bit nicer finish in there for you guys. Now what I'm going to do is to clean up my path a little bit here is go to my bidirectional here. And I'm happy. It looks good. Eliminate a lot of my repositions there. Should have a nice toolpath or a nice finish on that particular part. So now I'm going to come in here, and like saying before, is let's tighten it up. We'll just do a 10th step over, save and calculate. And we are using a 1/4" end mill, and we do have some smaller areas in here. So what we'll actually do is, once this is done calculating, we'll come back in there and do our rest machining, and basically just kind of finish off the areas that it wasn't able to reach with that 1/4" end mill. And like I said, that 3D constant step over, you know, the way that the path is coming along with the tool stepping up and over is a great spot to utilize that rest machining in there. So. And if I
yeah, Kevin, that looks just super cool. Super accurate. I mean, that's amazing. It's beautiful toolpath.
And it's so easy to use. That's why, like I said, that's why it's one of my favorite ones to use here. Okay, so now we're going to get a real nice looking finish in there. I did a 10th step over and whatnot, but I know I still have material in there. I can do my solid verify and do my stock targeting comparison and see it. But what I'm basically going to do is come in here, make a copy, switch this over to rest machining, and we'll just go down one size and tool here. And I'm just going to do the automatic because I wanted to find everything that was left over, not just contained to that circle. Reference tool, we're using a 1/4. Passes. I'm going to leave it open for right now. And you'll see that we come in here and clean up all the areas that were left over. Now, 39th step over is going to be quite large for that 1/8 inch. So, like I said before, I'm going to come and match what I had as a step over prior with using that 3D constant step over here. Save and calculate. And there we go. Cleaning up all that material that was left over. Now, like I was saying before, the only spot that I'm not going to be able to get into is, that straight wall right over here. And, like I said, we can come in here with horizontal, get that machined out with a flat end mill, or just, a pocket operation or iron machining operation, whatever you guys want. But definitely it makes programming real easy using that 3D constant step over, coming back, clean it up with a rest machining, and you're done. So any questions with this part right here before you go on to the next one?
Yeah, Kevin, doesn't appear to be anything so far.
Hopefully we're not putting them to sleep, Brendan.
Well, I mean, silence is golden. That's what they say.
Yeah. All right, 3D constant step over. There we go.
I think, just one thing I'd like to comment on, Kevin, just as you're opening this next part, is everything that you're showing here tonight is really super cool because, it's showing the level of control that you have over all of the toolpath. I mean, a lot of other systems out there, they claim, oh, it's full automation. It does everything for you. It's you don't have to think about it. But from all of the machinists that I know, including yourself and, Ken and Scott and Greg and all the people that we work with, all of these guys want that, they really want that minute level of control.
Oh, absolutely.
And so it's super cool to, that you're showing this tonight. So, You know, automation is good, you know, for hole drilling and hole recognition and, you know, that kind of stuff. But, you know, I think that's probably about as far as it goes. I mean, you know, you really want to have the ability to kind of drill down and have that super precise control over these toolpaths.
Yeah,
So,
absolutely. And
very cool.
definitely have all the areas to control whatever we want here. Okay.
Definitely.
So we do have what controller is that? Is that an Xbox controller?
Looks like it. Sure.
I'm not much of a gamer, but okay. So going to do another 3D constant step over here. Just throw some quick toolpath down and have basically a finished off part here. So what I'm going to do is grab our tool here, use our ball end mill, our drive. That's actually I'm going to have it follow the outside perimeter here. And same thing for the constraint. Contain it just to my 3D area that I'm looking for here. And we'll leave everything centered. This one I'm actually gonna, I'm gonna have it step down, but we'll leave it as 0 for right now. Passes, I'm gonna tell it to go to that point right there and maybe to stay above by 10 thou. Let's just, I don't want to reverse my, well, actually, no, I want to start from the center on this one. Save and calculate real quick. All right. And nice toolpath right there. Starting from the center, working our way out, kind of following the contours of everything that's going on here. Now, if I want to get a little bit farther down on my wall here, what I can do is do an offset. So I want it to go down, let's see what this gives us here. And now we're getting all the way down to the floor here. Now, we do have a little bit of repositions going on, so we can come to our passes, or I'm sorry, our link, and turn our bidirectional on. Should have done that first here. So, real nice toolpath. We're going to get a real nice finish out of this part here. Now, one thing I've been kind of skipping over here is under 3D constant step over, we do have limit of offset numbers. So what you can actually do is you can actually limit your lines. So let's say we just want to do 5 lines. Do save and calculate real quick. And it should do the outside perimeter. Yeah, it's just going to do the outside perimeter 5 lines. Now, I know you guys are looking at here and saying, well, there's more than 5 lines here. Well, there's actually 10. And what we're compensating for there is the horizontal 5 times and the vertical 5 times. Just kind of doing an outside boundary there. So if we turn that off, we're going to cut the entire part. Now, let me just kind of get our toolpath back how we had it here. And the adaptive variable side step. So basically, kind of how that works is kind of like a projection. So as the Z steps down, or as the wall of that Z goes steeper and steeper, the toolpath actually is automatically kind of adjusting for it and getting farther and farther apart. So a good example is you'll see how close our lines are here. And as they get farther around more to a vertical wall, our step overs are much greater. So that's the adaptive variable. So we're not wasting time doing those continuous tool paths on a straight up and down wall by stepping down just that small minute. So definitely if you guys are doing real basically straight up and down walls only with a 3D surface, that's where you want to turn on your adaptive variable side step. So Any questions with this part? All right.
Yeah, Kevin, nothing so far. I think most of the questions really were kind of about hardware tonight, which was kind of interesting. Yeah, so maybe we should kind of think about doing a little bit of a session some other time on
Absolutely.
Something like that. But if you have something else to show, please do.
Well, this is my last part, and for those of you guys that know Sydney, Sydney is our SolidCAM professor, and I asked him, I said, hey, got any good parts for 3D constant step over? And he hands me this thing.
Yeah, what the hell is that?
I don't know, it's pretty big. He's like, I want to see it cut, so we're going to cut it for Sydney. But like I said, with this particular one here, this would be a 5-axis here, just, well, actually, no, not 5-axis. We could do these internal fillets here using different Toolpaths. But what I'm going to do is kind of skip over the internals here and just kind of get our general Toolpath on the outside. So we'll just do our 3D HSM here. Got our constant step over. I think I have a tool in here. Yep, one and only tool. And we'll just leave this on automatic and leave this one automatic passes. This one is in metric, so that's why it's showing 1. Sydney sent me the part in metric, and those foreigners, they like their metric. So save me calculate here. Oh, dang, I forgot to reverse it. Yeah, and literally this part was, Sydney hit me up about 20 minutes before the class started and said, I want to see this one. So this is definitely way off the cuff here.
Hey, Kevin, all the greats have their moments. So this is your Waterloo right now. So
time to shine. All right.
Yeah, okay. What's cool too, and what's the diameter of that part, Kevin? That's it seems like
it is, well, 350 millimeters. So.
Oh, look at that! He's got to convert it.
Yeah, I got to convert it. So about 14 inches.
That's awesome. I love that. I do the same thing with my Canadian customers. For everybody here's listening now, so yeah, I do the same thing. They're like, well, well, but actually, you know what, Kevin? What they asked me to do is they asked me to convert the U.S. dollars into Canadian dollars. No. So I'm like, well, I don't know if I can do that, but I'm sorry. Please continue.
Thank God for Google, right?
Right.
Okay, so this is just standard right off the cuff. So now what I want to do is I'm getting more, if you look here, getting some more straight lines going on here. And I want more circles in there. So, and if we kind of zoom in here, you'll kind of see, we're kind of getting straight line movements here, and then we're getting a lot of reposition. So what I'm going to do to clean up that toolpath is come to my drive, do manual, grab that guy, and now we should get real nice spiral, starting from the outside, working our way in. And while this is calculating too, guys, for those of you guys that are new and would like to challenge yourself a little bit, if you guys go to our website, under subscription, we do have the new SolidCAM certification, and Greg Payton and Mark and myself have kind of put together a certification course of basically test your knowledge. What do you guys know? Associates test is going to just cover the very, very basics, just face mill, pocket profile, drilling, and that's it. The professional test is a three-part series test, and it's going to kind of get into a little bit harder of things, but kind of the first segment is just kind of covering more iron machining and pocketing. Segment 2 is going to be kind of covering some HSS, HSM, and segment 3 is does have fourth axis, but it kind of combines all of the stuff above into down below. So for those guys, like I said, I know a little bit of repeat here, but for the guys that are new, definitely come here, check it out. If you guys are on subscription, these tests are free to you, so definitely come take them. You know, love to see we got quite a few certified users already popping up in there, and we're actually going to be adding a post processor one to the certification too. So if you guys want to test your post skills out, you guys can do it that way too. Okay, so now we have a much better spiral here. You know, doing basically nice circles. Yep, I want to make sure because I was seeing some jump around, but yeah, doing nice circles, keeping in contact with that material the entire time, starting from the outside and kind of working our way in. So like I said, real easy to use, guys. Like I said, this really kind of goes well with the rest machining too. So like, you know, throw a couple, you know, a toolpath, a 3D constant step over, and then come back with a smaller tool and just kind of clean up those little areas that were left behind. So.
Yeah, you know, Kevin, and again, my apologies. I meant to chime in there when you were calculating that toolpath, and I was muted and I couldn't unmute myself for some reason. But no, my apologies. But one other thing that I do want to say, Kevin, do you have another part here, or are you about to wrap this?
Yep, this is it.
Okay, sounds good. I did want to say one more thing, and we are going a little bit over time, but it's very important to talk about this. You know, we always talk about SolidCAM 5-star support. You know, Kevin is on that particular team. We have, I think we've got 8 guys now who are a part of that that particular program. All of our guys are located in the United States in specific time zones. You know, when you call our guys, you know, you're not getting somebody from, you know, India who is, you know, kind of can't speak the language, trying to, you know, find the answer in a book somewhere. All of our guys are either programmers or machinists or a combination of both. So
we're all both.
Exactly, yeah. You know, in fact, a lot of our guys are, you know, guys who have owned their own machine shops and, you know, have since come to, you know, to work with us at SolidCAM. So, you know, again, we take a great deal of pride in the support that we have at SolidCAM, and you know, I just cannot reiterate that enough. You know, we take a great deal of pride in the support system that we've built. You know, all of our guys are just, you know, just right there, you know, ready and willing. You know, we're kind of geeky about it, to be honest. You know, we all love to talk about, you know, tooling and fixturing and, you know, programming and all that sort of stuff. So, you know, don't be afraid to give us a call. If you have a question, you know, that's what we're here for. That's what we get paid to do. So, you know, but again, you know, Kevin, thanks so much for doing everything you did here tonight. And you know, we'll, you know, if there are any questions about any of this stuff, you know, just give us a call. And you know, if you want to have a more personalized presentation about it, you know, we can set that up for you too as well.
Yeah, absolutely. And the nice thing too is, you know, one thing I want to kind of convey too is, you know, we have a lot of you guys in here that are attending every week, and definitely appreciate that. Send those emails over to me so I can have you guys, so you guys don't have to fill out the registration anymore. It will automatically be inserted in for you guys, and all you guys will actually get is a link sent to you via email. And all you guys have to do is just click on that link, and it will automatically pop you into the webinar. So, and then one other thing too is, if you guys got some really cool parts that you guys did machine, take a picture of it and send it to us, because we have our Instagram page that we just kind of got going here just in the last day, And I mean, send us those cool pictures of your Toolpath, or even a part, and we'll put that up on there too. And like I said, definitely let us know what we can do to help you guys out. And I did get a request to post my email again, so let me copy and paste that in here. And it is kevin.rankle@SolidCAM, and Rankle is kind of a weird name, but didn't really have a choice. Okay, so I just put it in there. Greg, do you see that now?
Yeah, you know what I'll do, Kevin, is I'll just copy and paste that into the chat area as well. So let me just reply to that.
Yep, you said you got it. So like I said, cool. shoot me those emails if you guys are want to be in every one of these, and that way you guys don't have to. It'll save you a little bit of time, and like I said, any other ideas that come up along the way that you guys feel that would make the night class a little bit easier, or something you want to add, just let me know and we'll get it changed. So just had to do a little bit of work with GoToWebinar to get that access, but we got it set up for you guys, so you just let me know who wants to be in there. But I guess with that being said, guys, thanks again. Really appreciate you guys spending the night going through these classes. I had a customer email me the other day that he says he just signs up every week, but he can't. He said unfortunately it's too late at night, he can't attend, but he just keeps signing up to make sure the class keeps going, so I sign up. So don't worry, the classes are not going to be ending anytime soon. I kind of went through a schedule of lineup earlier this week, and we have tons of classes out there, especially from your guys' ideas too. So it's not ending anytime soon, so don't worry.
Awesome. Yeah, and again, just to reiterate Kevin's, thought from earlier, if there's anything that you guys have, anything you want to see, something, whether it's, a course suggestion or something, just to outline something a little bit more in detail, just let us know, and we'd be happy to, to create a class for that. So, that's super cool. We can certainly do that.
Absolutely. All right, guys. Well, look forward to you guys being here next week, and we'll see you guys next week. And like I said, this video will be posted on YouTube at 1, 2 o'clock in the morning. You guys should be able to see it. So, all right, guys. Have a wonderful night. Thanks again. Bye-bye.
Take care, guys.